All right, so I just wanted to go through the StatCrunch calculations that were used in example 2, and also to show you a couple of different ways that you could approach the same problem. So in finding the test statistic for our sample proportion of 0.483, right, we use, well, it's based on the central limit theorem. So we assume that the sample proportion has mean equal to 0.366 and standard deviation equal to the square root of 0.366 times 1 minus 0.366 all over 29. And when we found the z-score for the sample proportion of 0.483, that turned out to be about 1.31. And so to find the area to the right of 1.31, we calculate with StatCrunch, having gone to Stat Calculator's normal calculator. We compute that left area, and we said it was about 0.905. This confirms that. And then to find the area we actually need, the right-hand area, we would subtract that from 1. So that's where we got the 0.095 for our p-value, which again is the probability of getting a p-hat at least as big as 0.483 if there's really no difference between BSc students and the state of Alabama in terms of political affiliation. All right, so a 0.095 p-value is fairly rare, right, to occur just by chance, and in fact, it was less than our predetermined cutoff of 0.1, our alpha equal to 0.1. And so because 0.095 was less than 0.1, we rejected the null. So just as a way to kind of reinforce that there's more than one way to do this, right, we calculated the rarity of our p-hat by first calculating its z-score based on the central limit theorem, giving us a normal distribution. But we could actually do this sort of directly using that distribution without calculating a z-score. So remember, the central limit theorem says that if we have a large enough n, which in this case, right, we didn't quite have, then the distribution of p hat is normal with mean equal to the population proportion 0.366 and standard deviation equal to the square root 0.366 times 1 minus 0.366 all divided by 29. If you carry out that calculation, the standard error is 0.09. And what we're interested in is the left-hand error, or what the calculator will give us is the area to the left of 0.483 for that result. And we see that, right, we get the same left-hand area that we did after we found the z-score for p-hat and then used that with the standard normal distribution. Right? So one uses the score itself, the p-hat itself, just with the normal distribution guaranteed by the central limit theorem, and the other calculates a z-score for p-hat and uses the standard normal distribution instead. Both get you the same result. One other thing to be aware of is that we can actually run a hypothesis test with StatCrunch. So if we go down under Stat to Proportion Stats and one sample, here we don't have raw data, we have a summary. So we do one sample with summary. And we tell it what happened in the sample. So we had 14 identify as Democrats out of 29 observations. And our null hypothesis was no different than the state of Alabama, so that's a 0.366. And our alternative was a suspicion that college students at BSc would be slightly, we didn't say slightly, but would be in general more likely to be Democratic. We're not doing a confidence interval for P, but if you wanted to, you could click that and it would give you the confidence interval. So we just are going to run the test, hit compute, and here we see that it calculates the sample proportion for us, which was about 0.483, I had rounded. The standard error, which is the 0.089 I used a moment ago in the StatCrunch normal calculator. The z-score, which after you round is 1.31, and then the p-value, which is about 0.096 in this case instead of 0.095 because of where the rounding took place in our calculations. All right, so p-value, z-score, standard error, sample proportion, all that's done automatically if you tell StatCrunch the number of successes and the number in your sample. All right, that's going to do it for this brief video. I look forward to seeing you in class, and please let me know if you have questions.